Hello everybody, welcome to the NASA Earthdata webinar implementing the ISO 19115 model for NASA Earthdata. This is your host, Jennifer Brennan. While everybody is logging in, we'd appreciate your feedback on the two optional polls at the bottom for those of you who are logging in. I've got 2 p.m. Eastern Standard Time, so let's go ahead and get started. I will first begin by going over a few housekeeping items related to the webinar. To ensure best audio experience, the conference has been placed in silent mode. If you have any issues or questions, please enter them into the Q&A pod located on the lower right-hand side of your screen, and this works like a chat. This webinar will be recorded and posted to the metadata page within the Earthdata wiki. All presentation files will also be available for download at the end of the webinar. The webinar itself is 1 hour long, 45 allocated to the presentation and live demonstration, with another 15 minutes or so for the question and answer period. After the speaker has finished his presentation, we will then move to the final set of polling. And answer period will follow. As mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar by using the Q&A pod, and again, you'll see the right-hand side here in the lower right at the moment. Okay, questions will not be answered using the raising hand function. This has been disabled. What we'll do is all questions in Q&A pod at the end. One final note, depending upon the volume of questions that are received, we end the Q&A period additional 15 minutes to 3:15 p.m. Eastern Standard Time for those of you who wish to stay on the line. Let's move next to the agenda. During the first 10 minutes or so, our speaker will provide you with an introduction to ISO standards and will discuss the value, challenges, and terminology. During the next minutes, we will discuss a baseline ISO model with the specific attention being given to the essential classes and attributes. Finally, we'll finish up with an overview of the issues and relevant discussion topics. It is my pleasure to introduce our speaker today, Barry Weiss, who is the Systems Architect for the NASA Soil Active Passive Mission, or SMAP, at NASA's Jet Propulsion Laboratory. Barry?
Hey, good afternoon or good morning, depending on where in the country. I'm going to welcome you to this talk about ISO 19115. Jennifer has I work on the Soil Moisture Active Passive Mission, or SMAP, and I'm pleased to start flying, and we are doing well and looking forward to data in the not too distant future. I also noted by looking at online by the polling that a decent number of you are slightly familiar with ISO, and many of you are not familiar at all. I'm going to try my best to address both well as I go through this talk. So I will proceed in such a way to assume a few of you have strong familiarity with ISO. All right, so starting at the top here, why ISO? Why are we pushing in this direction? And I think most of you may already be familiar with this. If you're working with data products, you're familiar with the fact that many different data product providers just have their own metadata, and they put it together their own way with their own attributes or elements in the product. They have different names, so a different product, actually looking at a different set of metadata, and it isn't a nice apples to apples comparison. ISO provides a standard that we all can use. That's a good, strong starting point. ISO provides a means we can represent it the same way. Now, in today's talk, I'm going to talk the earlier part, the part dealing with the common model that everybody uses. I am thinking about and considering, and at the end of the talk we'll discuss this, or I'll mention this, having 1 or 2 more webinars where one of them would be how we commonly represent it. Oh, by the way, one other thing about ISO. It's very rich. It has an awful lot of capabilities that go way beyond data discovery, which is generally what people are interested in and where I'm going to spend most of my time today. All right, so the next slide, the slide that's in front of you now, lists 5 documents that detail the ISO model. Folks who have read or looked at these, and I know some of the people online have, will agree with me that these documents are, indeed, they can be quite tedious and long. And I think what most people need to know or need to find is what do you need to find? What do you need to know in order to get into your product metadata? And again, that's part of what I'm going to try to do today. In SMAP, we used these top 2 models, the ISO 19115 and the ISO 19115-2. However, we are moving strongly towards ISO 115-1. Don't ask me why it's later, but it is a much better model, and 19157. And I will mention them to some degree as we go forward in this talk today. Again, I think part of the goal here is to try to give you a flavor of what this is all about without having to read these documents. All right, so what's the challenge of ISO? Well, there's quite a few challenges here. First of all, we want to generate metadata that conforms to the standard. If you are a NASA person, I understand some of the folks here are not, but if you are a NASA person, you also want to make sure that the metadata you put in there are metadata that the data center that's distributing your data needs, and they recognize it as what it's supposed to be. In other words, in this particular field, I put this particular value, and the data center knows that's the value you're putting in that field. The most important thing we think about metadata is ease towards discovery by the data community. So that's the most important thing, but I'm going to emphasize the fact that metadata has a lot more value than that, and we shouldn't restrict it to just that. If you're a NASA person, you may be familiar with the ECHO Clearinghouse, which provides a means by which people can find their data regardless of what data center it's at. ECHO has also specific requirements about particular metadata elements. I will allude to fields that if you fill them the way I'm going to indicate you should, you will be fulfilling most of the ECHO requirements. Finally, metadata really should be an aid to long-term data preservation, and that's where I'm going to point out a few other things that we should get into the metadata. Documentation that describes the metadata, certain kinds of scientific parameters that scientists might want to use to describe their metadata. Other elements that have to do with things that certain users may want to see or wish to find in the metadata that go well beyond the point of data discovery. As I also mentioned, there's a common means to represent this. Again, this will not be in today's talk, but it is something that I think is important and many of you may be interested in. How must ISO metadata be represented so that everybody has that common format as well as the common content? Okay, so again, the objective for today, as I indicated before, I'm going to give you a sense of the particular classes and elements that you need to provide in order to conform to the standard, and I'm going to limit it pretty much to the ones that are most critical, the ones that are most central. Again, this can be expanded greatly beyond that level. I'm going to give you a sense about how you incorporate them into some NASA-specific identifiers, some of the things that NASA requires that you must have. And I'm going to give you a sense of how you construct this into a model that you can use for yourself. Beyond that, again, I will talk a little bit about the documentation, and I'm hoping I can help you avoid it. As I like to tease people who say they want to read the documentation, I say take it home, take it to your bedroom, you'll be asleep in 5 minutes, and you'll need no drugs. Really, it can be that tedious. Okay, some common terminology that you really should know in order to move forward. Again, ISO employs an object-oriented approach, so when they express how the metadata model works. Therefore, as you'll see in the upcoming slides, I'm going to have UML classes that cover major concepts, and then the attributes in those classes are the details. And so I'm going to go through that. I'm going to pinpoint various things there. So get used to the fact that we're going to talk about classes that can be instantiated multiple times and that they represent slightly different elements or slightly different, instantiations of that particular class. In other words, a different use of the same class. I'm going to talk about granules, and I'm going to talk about collections, but in ISO land, we use the word series to identify a collection. We use the word data set to define a particular granule. And again, you're going to hear me say this often, so hopefully you've absorbed the concept and you'll be able to follow me as I go through the slides to come. I want to point out that at least for SMAP, and I think this is going to happen, talking to some of the people online already that I recognize doing other missions, that most of us, if we're going to do this, are probably going to have to generate two sets of metadata for our files. One that will be a series set, one that covers the entire collection, which will be constant. It can be edited or it can be curated by a system engineer and then plugged into all of the files. And one that has to be done in an automated fashion because it will be different from one particular data set to another. So again, these two terms, data set and series, become very critical as we go forward. Finally, I'm going to mention code lists. These are like enumerated lists that you're used to, except they are specified by the ISO model. And they're very useful in terms of the fact that if you use them, then you can clarify in associated fields in a particular class what that class is about. As I said a moment ago, we can instantiate multiple times, so the use of these code lists in that particular class can indicate what is in that class or what that particular instantiation is about, what it's for. All right, so now let's start going into the model itself. This diagram, I'll agree with you, is quite complex. But again, I think the important points that you're going to gather out of this is the central core of the ISO model. This particular class that I've circled now is MI metadata. In 19115-2, it is the central class. It describes the metadata. And as you'll see, there are many, many classes that are aggregated to it. And I'm going to elucidate upon them now and then move into the model in greater detail. So first, there's DQ data quality. I think the name tells you what it's about. It's a means by which you can indicate quality of the particular product. Then there's DQ grid spatial representation. And as you might expect, it indicates how we indicate a grid and how that grid is formatted for the use of that particular product. There's acquisition information. Now this is a rather broad one, and when I get into it later, you'll see how broad acquisition information is. But you can indicate things about the platform that the instruments are flying on. You can indicate information about the instrument itself. You can indicate information about the particular targets you're looking at. You can indicate information about the ambient conditions that are in that particular data set that you're looking at. And I think there are even more than that, but those are the ones that come to mind right now. Data identification. Okay. The MI metadata class up here is directed towards the metadata itself. This is directed towards the data that contain or that the metadata references. And again, I'll get to this in a little more detail quite soon. The EX extent, this is something that you're all familiar with. This will indicate the spatial extent of the data, the temporal extent, in other words, the time period that's covered, and maybe even, if necessary, the vertical extent of the product. Keywords. I'll mention this only briefly. There are some of my colleagues online who are involved with ECHO. ECHO will require GCMD keywords. I will indicate to you that they need to be plugged into this particular product. So this is the central core. Now the next slide I'm going to go into is not going to deal with each of these individual ones, but classes that are used all of the time. You're going to find, if you get into ISO, that almost all of the classes have a reference to something called CI citation. CI citation is a means by which you cite either a file or a document. And it will be used by both, and it can be used multiple times in various classes for that particular purpose. So let's look at a couple of details now, as I promised we would. The title in the citation. Well, what's the title about? The title for a document clearly is the title of the document. If it's a file, however, it would be the name of the file. And again, we can differentiate between data sets, which are individual files, where it would be the name of a file, and a series, which is a collection where that title might be the long name of that particular class that we use. In other words, a long descriptor that describes that entire series. Again, what else is here? Well, addition. Addition should be pretty evident. It's either a version or an addition. An addition if it's a document, a version if it's a particular file. All right, then there's the identifier, and I will go into more detail on identifiers in a moment over here. We'll wait a moment and stick to this particular class for a moment. Identifiers are short identifiers that can be used in various ways to classify particular elements, and you're going to see how this gets used in SMAP and how I recommend people might use it in their ISO metadata. Note that this particular class is aggregated to the citation class. It's one that indicates a date. By now, I think I've pointed out the four most important things that I think one needs to show in a citation: a title, an addition or a version, an identifier, and I'll get more into that, and the date. Now note, when we talk about the dates, there are three different kinds of dates we can discuss. Creation dates, good for files. Publication dates, good for documents. Revision dates, good for either. This is my first example of a code list. Note the data type code list up here. Here's the data type code list. So this code list would contain one of these three values, indicating what particular condition we're talking about with that particular date, what kind of a date it is. All right, now let's go on to CI responsible party. Responsible parties can take many, many different roles. Note the role code here. This role code has the role references the role code. The role code is this particular list of possible roles that can be represented in the CI responsible party class. All right, let's talk about a couple of those roles that are going to be very common, certainly in the NASA situation. The distributor. Well, the distributor is clearly the data center or the DAC. The originator. The originator is likely to be a reference to the mission involved. So for SMAP, this would reference the SMAP mission. For ISAT2, the ISAT2 mission, and so on. Point of contact. This is also a reference to the DAC, but this is even more important because here we might be looking at some of these other aggregated classes down here where the point of contact would indicate addresses, telephone numbers, and various resources that that point of contact might make available to people who want to find the product. The processor. This references its SMAP, the SDS, our science data system, the folks that I work with to generate the particular products. And finally, the resource provider. Who gives us the money to do the job? Well, NASA, maybe NOAA, maybe some other agency that is involved with providing the data. So this role indicates what the role is, and then when you name the person or the organization or the position, clearly that instantiation then tells the person what the role is and then provides information about that. And then note all of these down here can be added in based on whether or not they're relevant information about that particular role. All right. Finally, as I mentioned before, MD identifier. Like citation, MD identifier is all over the place. It references very simply a code, which is a relatively short character string in most cases, which is used to classify a particular product or a particular element. Some of the things that we use in SMAP for this is the short name. If you're a NASA person, you know immediately what I mean when I say that. Also, other identifiers in there could be things like digital object identifiers, universally unique identifiers, various kinds of things that also are codes or code information that provide more detail about a particular reference that you're making at that time. Now, as I indicate here in this particular box, as I move my arrow over here, here's one place where SMAP did pick up a little bit of ISO 19115-1. As I said at the beginning, SMAP tends to use ISO 19115-2. -1 comes later. Please don't ask me why it's later, but it is. We have a descriptor that we plugged into here that you don't see in here. That descriptor is a means by which we differentiate between different instantiations of this class. And again, I will show you a detail of this a little bit later in the present. Okay, so this slide I'm not going to go through in detail. What I've done so that those of you who pick up these slides later on can do is, as you see me go through the details on the diagram, and on a subsequent slide in many cases, I will write some text that references what you saw so that you can remember what you had. So this has already been covered. We'll go to the next slide. MD metadata. My friend and colleague Ted Haberman provided me with this. MD metadata as it is, if you look at the previous slide, I had MI metadata. That's a 19115-2 instance. MD metadata here is a 19115-1 instance. However, what I'm going to pinpoint here is either absolutely identical or very close in both, and elements that you really must provide, or I believe you must provide, in order to get into a NASA standard usage. So first, the metadata scope. The metadata scope up over here should indicate whether you're using a data set or series. In other words, this particular instantiation is a data set or series. As I indicated before, that's really, really critical, knowing whether you're talking about a large collection or an individual instance. The metadata contact. The contact references, if you check it out, a CI roll code. So basically, when I look at the contact, I can find it up here. Actually, let me, it's in here, it's in the CI citation. The citation will indicate a contact, and that contact should indicate the point of contact where people are looking for particular elements. The metadata identifier. The identifier, and by the way, in ISO 19115-1, I believe it's just called simply identifier. Up here should reference the product name if it's data set. But if it were talking about a series, I would recommend something like a long name. So depending on what you're using, you might have a different element in there. The date info. The date will indicate a different thing again if it's a data set or if it's a series. If you're dealing with a data set, you're going to give the creation date of a particular file. If you're dealing with a series, you're likely to give the version date, the date when that particular series began to be distributed. So in other words, it's the date that that particular set of software was generated and then began to get distributed. The metadata standard name and the standard version should represent the most updated version of the ISO metadata model that you're using at that particular point. Again, I want to point out here, and by the way, the contact is over here. I just got a little lost looking, but here's the contact information that I'm talking about here, where you reference CI responsible party, and then the party would be the contact. Sorry, I got a little dizzy looking at my own slides, so I can understand why some of you might get dizzy as well. Hopefully, I can help you get through this as we go forward. All right, so having said this again, this is the ISO 19115 model. If you look 2 slides earlier, you'll see the one that is the 19115-2 model. You'll see they're very similar, but not identical. All right, MD data identification. Again, this is the 19115-1 model. This one is almost identical, however, to the one in 19115-2. What am I going to point out? I want to point a couple of things that are really important here that you might notice. And by the way, these appear in a couple of places. The language, you should probably indicate that you're doing it in English, unless you're not. The character set, it's probably UTF-8, unless you're not, but I would say in most cases those are going to follow through. The citation. The citation in MD data identification is really where most of the major information goes. So, the citation title. If this is a series, it's going to be the long name, as with the long name before. Note again, there's more than one place to put this. But here I think is really the most important place to put this. If it's a series reference. If this happens to be a granular reference, then the title is going to be the name of the file that you're talking about. The edition in a series is going to be the current release identifier. The edition up here would be the version of that particular file that you're dealing with. The date here would be the date of that release that you're talking about, because it's a series. The date up here would be the date that that file is generated. All of that gets merged into the CI citation class that I mentioned just moments ago. There's a couple of other important points here that I think you should fill in. The abstract here, describe the product. A couple of sentences, that's all you need. The purpose, why do we generate this product as opposed to some other? The credit, give somebody credit. Somebody worked hard at doing this. Somebody did a lot of sweat and deserved to be mentioned, or some organization a lot of sweat, and they deserve to be mentioned. I recommend that for the status class over here, you plug in ongoing if you're in my situation where you're generating data for the first time. Clearly, if the data are completed and you're in a data center and you're rebuilding ISO, you'll find other elements that would be more clear representation of what this is about, indicating that these data have been completed and are no longer being generated. The geoscientific information that you need to provide here, let's see, MD topic category is the topic category, this particular piece. You'll find all kinds of things in there, farming and agriculture and whatever. In many cases, you may not have a good value to do there. I do recommend then you use the term geoscientific information. That's certainly something that we're all using. I also indicated that keywords are an attached or an aggregated class to this. GCMD keywords are required by ECHO. In my experience, I went to my friendly friends at the DAC and I said, what do you need? They told me what they need. It wasn't very hard to fill it in, and I can, if you wish, provide you with a model of how that gets filled in. If you're not dealing with NASA, you may not need to deal with the keywords. Okay, so let's start talking about some of the more specialized classes. The data quality class. Okay, it's centered here at DQ quality. There are several aggregations into that particular class. One is Lineage that I'll talk about later. Lineage is where we indicate provenance. Not for right now, we're going to put it off for a slide or two. But for DQ quality, there's first of all the DQ element. The element is an abstract class with all of these possible specific classes attached to it. And I'll list one or two of them that we use later or just momentarily. But you'll notice a couple of things that are important here. Evaluation method, it's important to indicate that. So you can indicate how you evaluated it. You can describe your measure in some form or another. These two are probably the most important ones in this particular class that you probably should list. DQ scope, you used something to come up with your measure. Something in your product, something was there, was the mean came up with these values. Here you indicate what that scope is. You indicate what particular elements you used that were in the product. So for instance, in a level 2 SMAP product, I would list the element that is listing soil moisture. If it were OCO, I would be listing something that would perhaps indicate the OCO concentration in the atmosphere. It depends on what it is, but that particular element would be referenced here. And then people would know the basis for how you calculated the quality measure. Here, DQ result is how you list the result. Note that this class actually has two specialized classes. If you go into another form, there's actually a third one. One is where you just can list a quantitative result. A second one is where you can actually give a conformance result, where you compare the result or provide another means to that result. In other words, to better assess what that quality value is. Since multiple instantiations of this can occur, you actually could do both on the same quality element if you wish. Now, I'm going to pinpoint two elements that we used in SMAP that I think would match nicely with what has been done in NASA before. DQ completeness omission. Completeness omission is very similar to something that a lot of you guys in NASA would know, which would be QA% missing data. This is basically the same thing. How much data are missing in that particular element? Another one is domain consistency. Those of you in NASA would be familiar with something called QA% out of bounds data. Well, this is the reverse of that. This is what percent of the data are within the domain. The one previously used in NASA would be how much of the data are out of the domain. Nonetheless, I strongly recommend that everybody use at least some data quality elements in their particular product. So again, here's some details on that particular slide that I just showed. I want to pinpoint something about another NASA model, our NASA model base called 19157. 19157, I think, is a huge improvement over 19115. It was not completely stabilized when we were doing SMAP. We did not include it, but I want to indicate a couple of things that I think are really helpful. In 19157, you have an entire class that can describe measures, an entire class that can describe evaluation methods, instead of a single attribute as we have in 19115. I think that's an advantage. In 19157, DQ result has a third specialized class, one that allows for a descriptive result. I think more and more people are recognizing that sometimes a qualitative result is as valuable as a quantitative one. And this allows you to do that. This enables one to actually put text in there that is a means to evaluate the result. It's not a comparative piece that you already have there, but it's another means to give an assessment of the quality of the product. So it also provides, by the way, even better than that, a really broad suite of data quality measures, much, much more detail. It's a whole library of them, a whole thesaurus that you can use. And this is, again, one of the topics that maybe I could bring up later this spring or summer, but something that I really would like to encourage more people to use over time. Not that the data quality in 19115 is not good, but that this is just much more rich and much more capable of providing good data quality information in your metadata. Okay, Lineage. A moment ago I mentioned this. This branches off of the quality. This is a means by which we indicate provenance. Very important information. This particular area that I've boxed in over here is where we indicate, shall we say, procedural provenance. In a moment, I will talk about, over here, I will talk about data provenance. So this is the process step. This is particularly what particular things were done in order to get the data we had. So this particular box over here lists the processor, and notice it references a party. So here is where I say this is the SMAP SDS doing its job, building the software that is needed in order to get the result done. Then over here, I indicate the date and time. This would be the date and time when this particular product got done. For those of you in NASA land, this would be the production date time. I indicate a description here. This allows me to describe the processor. So it's a little bit more information about the processor and what it does. Okay, let's go over here to EOS processing. I'd like you to note the EOS header here. This indicates that this is something that we, NASA, did in a specialized class done for NASA. I'll mention a little bit more about that in a moment. Note the identifier here. We've talked about MD identifier. The identifier here would be an identifier of the particular executable. We usually use some kind of a short character string to describe the executable that generated the data. It would go here. All right. Next is a software reference. If you have, and ISO, by the way, SMAP hasn't done this yet, but plans to, write a document that describes the software that was used to generate the result. I'm not talking algorithm theoretical basis document. I'll be there very soon. We would reference it here. Note it's a citation, so it's a citation to a document. Okay. However, EOS algorithm has more details about the algorithm. It includes an additional citation and a citation. And what SMAP does is uses one of them, I do believe the citation, to cite the software suite itself that is used to generate the result. And the additional citation is, as I just mentioned a moment ago, the algorithm theoretical basis document. And for those of you who aren't familiar with it, this document is the theoretical basis of the algorithm. This document describes the software that was used to implement the algorithm. They are different. All right. Then down here, I have something that I think is very important. ISO any model is not going to provide everything that you need. So we create what we call additional attributes. Additional attributes in this particular region are additional attributes that describe the algorithm as listed down here, and I won't go into detail on those. But we have created the capability to list and provide additional attributes that describe additional information about the products and what they have. Okay, so again, more information on that. The LI Lineage class. This particular class is the class where you indicate provenance of the data. And here in particular, I want to point out that in SMAP, pretty much everything that we needed in the LE source class was referenced in a citation, this source citation. So most of the other things in here are optional. We didn't use them. We did put a descriptor in here for what they were. And every single element that contributes to the output, and in some cases this is 20 different files, has a particular instantiation in ISO. So for things like attitude and ephemeris and whatever else might be needed that was used to generate the data, there is one instantiation of this, and the vast majority of the information is in the citation. And indeed, I've gone through this before, so I won't in great detail again. The name of the contributing file is down here. The version of the contributing file is here. The date of the contributing file is an attribute that is aggregated into that particular class. If we use an identifier, because there is one, the identifier would reference a code over here. So I'm really iterating now, and you're beginning to see how the model does iterate. Extent. This one's easy. I think most of you will understand this pretty immediately. Extent is the means by which we indicate the region in terms of the geographic extent, or the time period in the temporal extent that is covered by the product. Now, one little thing to note here, it's important to differentiate between extent when we're talking about a series or a collection, and extent when we're talking about a particular granule. So for instance, when I'm talking about the geographic extent for a product, a singular granule, I probably am going to use a polygon to define the region where that particular product has data. However, if I'm going to talk about the overall region covered by a whole collection, well, with SMAP, it was pretty much the whole Earth. With many of you, it will be that way too if you're using a spacecraft. Now, of course, if you're using an aircraft, that might not be the case. You might have a much more limited region that you're talking about in terms of the overall collection, and an even more limited region in what you're talking about with particular granules. Again, the difference between a granule and a series on the temporal extent would be the same. With a granule, you're probably going to indicate the very specific time frame covered by the product. With a series, you might indicate a start time with no end time because you don't know what the end time is. Or you might indicate something more general in order to indicate the time period covered. Finally, do note that you can list a vertical extent. If you have a product that varies over layers, this is a means by which you can indicate that variation. Okay, again, more detail here. Acquisition information. Now this is a really interesting class. In SMAP, we use the EOS platform to indicate the SMAP platform. And again, you're going to see very familiar information here, a citation which cites the platform, a description, a means to describe that particular platform. And then you're going to see instruments. And again, we have two. We have a radar and a radiometer, so we instantiate this twice, one for the radar, one for the radiometer. These citations cite documentation about the platform or about the instrument at a level that can go out to the general community. So again, that's all done the same way. One thing you might be interested in for some situations is MI instrument can aggregate directly to MI acquisition information if you want. You don't have to do what SMAP did to do it. Note the EOS in front. That meant that SMAP did some special stuff here. What did we do here? We attached EOS additional attributes. These additional attributes over here are attributes that describe the condition or the position of the spacecraft in flight. Now, this leads to another really interesting piece that happened with SMAP that may not happen with you. Since we did list these elements here, and if you look at them closely, you see things like eccentricities, equator crossing times, equator crossing longitudes. These vary from granule to granule. Since they vary from granule to granule in the SMAP model, MI acquisition information goes in the data set or the granule set. However, if this wasn't here and you were only dealing with a platform or an instrument, well, they're pretty static. In that case, you probably would plug this into the series metadata instead of into the granule. So do note this kind of flexibility that you have as you're dealing with this particular piece. I also want to point out, and I think I'll move to the next slide here on purpose, acquisition information can provide information about an operation. In other words, something about a specific activity. You could do that. We didn't do it in SMAP. An environmental record about ambient conditions. A requirement. You can actually indicate particular requirements that a particular collection actually try to achieve, or even a particular granule, though I would think it would be more a collection. An objective, a particular objective area that you covered. All of these things can actually make the metadata more rich, and I encourage use of them. Okay, grid spatial representation. I'm sort of coming to the end of what's necessary, or I think is necessary in a model. So at the top here we have grid spatial representation, where we indicate a cell geometry and a cell geometry code. The cell geometry code over here indicates whether we're talking about particular areas or particular points. So I think that's important for you to indicate. You can indicate here the number of dimensions, and then over here in a moment to be mentioned, you'd indicate information about those dimensions. By the way, one other thing here, this transformation parameter availability is a means by which you indicate if in the metadata you can indicate some kind of a means of how you transform the data from how it was acquired in the original image to how it appears in the data product. In MD dimension, you can name the dimension, you can give a size, and if a resolution makes sense, you can also indicate a resolution. I'll indicate down here, without going into detail, don't have that much time, that the grid spatial representation splits between geo-rectified data and geo-referenceable data. Geo-referenceable data are data that are put on a common grid. So you have a lot of different data elements put on a common grid. In this case, you're probably going to almost do some resampling in order to get the data onto the particular model that you're showing. Geo-rectified data are data where you have a particular image, you know where a couple of image points are, and you plug that image onto a map. In SMAP land, this tends to match our level 1 products, while our higher products, which are on a grid, tend to go into this particular class. And again, not enough time today to go into detail. If you're interested, this could cover later. So, a couple of discussion issues, sort of coming to conclusions now. A couple of things that I've definitely about ISO that I think are important is, one, I showed you this with the CI responsible party class before. The responsible party class has in it elements that indicate addresses, indicate phone, indicate names of points of contact, indicate particular means by which the data are stored or made available. All of these things, along with other distribution information and constraint information, are more the matter of something that a data center or DAC would provide and not something that a mission would provide. I have left those open for those to be provided. There are some issues, however, because that means that they might change metadata. This is definitely something I'm going to be bringing up with NASA in the near term. I also mentioned to you multiple instantiations of the same class. In some situations, because you have a code list value, you can easily differentiate between them. But here's a situation where we had to do something ourselves to enable the differentiation. So, MD identifier code, as I've mentioned before, can have lots of short identifiers. In SMAP land, we use DOI, object identifiers. If you're familiar with these, cool. This is a means by which you indicate a landing page where you can always look for your data, and if landing page changes, the user doesn't know that. They still use the same reference, and they get to a new landing page. Short names, those of us in NASA know this well. It's a means by which we make it clear what particular product we're talking about. Version identifier, very important. You need to indicate what version you're showing. SMAP is now using universally unique identifiers for every instance of a product, so every single product will have a separate UUID. All of these things are there. However, without indicating some kind of other piece, the MD identifier description, somebody wouldn't know what instantiation is what. So what you see over here is actually the text of the description code that we put into SMAP in order to make this happen. Now, this is what SMAP did. I'm not saying this is what you must do, but I am saying that we do want to come up with some NASA standards, and I am saying that you should be aware of this because I think you're going to find yourself with a similar issue as you move forward. Okay, where do we go from here? I allude to a lot of stuff in a very, very good time. I realized just by looking at the questions that were being asked, some of how were, and what some of you were, most of you were saying things that I felt the same way about in terms of what do I know, how do I deal with the standard, then how do I NASify, or I understand some of it by notify the product, make it work with the agency that I'm within so that this information passes not only the ISO test, it conforms to ISO, but it also fits well into what your particular agency, your particular group is doing, and people know what fields contain what. All right, so a lot covered, and I do plan to spend the next 6 or 7 months working on some of these things. What can we talk about in a future session, or maybe I'm talking about maybe a webinar or even a seminar in the future? Serialization of ISO. In other words, how do we get it into 19139? I have some slides on that. I'll even mention them at the end here where you could get that right now. Enhancements. I've talked about 19115-1 and 19157. We could go into more detail on that, talk about how they enrich the metadata. Alternative means to express ISO metadata. As I said, required in this XML. XML is very machine friendly. It's not always human friendly. So SMAP went ahead and took the ISO metadata and represented it this way as required, but we also put it into the HDF5 product, and we have a certain model that we're using. And we know our friends in ISAT2 are using the same model. I could talk about this. I could pass more information on about this. Development of NASA standard practices using ISO. Okay, so we talked about the fact that particular elements should have particular fields. Where's the short name? Where's the long name? Where are particular other elements that we know ECHO will be looking for? Where the DAC will be looking for them? And again, I think we've set up something with SMAP, and I think we have begun to set up a standard, but it's not done yet. It's still in development. Storage and tracking of NASA ISO schema. We want to be able to make sure the schema we're doing is right. So I want to do something with configuration management, whereas you folks who are in NASA land want to begin to do this, you can make sure that the product ISO that you generate does pass the NASA schema. And if it doesn't, you get it corrected before you start to distribute your products. Incorporation of additional attributes. I mentioned that they exist. There are a lot of them. I think we want to avoid something that propagates constant new additional attributes. In other words, some configuration management where people can look to see which ones already exist, and if they already exist, reuse them as opposed to create new ones. And one thing I didn't mention that's out there is if you are doing additional attributes, you have to deal with both what we call a record, that's the record that indicates the value of that particular attribute, and a record type where you define it. And so this would do something with a better understanding of the record types. Now, I'll caution you, we really only have one type to expand that to some degree. And this is a conversation I'd like to have with them and settle over the next couple of months. Discussion of tools. Tools need to get developed. Build ISO tools, the design, level the content, tool, and use it. We need to set up something where people are aware of each other's tools, becomes more common. So use it. Correspondence between ISO and the Unified Metadata Model. I don't know how familiar you are with the UMM, but there's an attempt at EOSDIS to try to take various different metadata that are out there and create crosswalks or models between them. In other words, means to translate from one to another. All right. So, are we all aboard? I'm really hoping that at the beginning of what I said translates to you. We don't want a Tower of Babel. We need to have a common model. Do I think ISO will be the common model in the end? I don't know. But I really strongly believe that if we don't get on board to generating a common international model as the volume of metadata grows, Earth science metadata grows, we're going to be left out. We need to be in the conversation. We need to be in development, and we need to be people who are actively contributing to it. And so I really do believe that even though for some of you, hey, this is a drag, it's a lot of extra work, we do need to figure out how to get involved, how to do it, how to get it into our products, and then how to standardize it, at least in the NASA where it still fits the international ISO. So how do we get there? Well, one means of getting there is SWG, you NASA folks. I'd be interested if you can propose working groups, but if you do, it would be a relatively limited, not this whole shebang. That's not something that is mean group. We can talk about getting a group started that would be dealing. Also, I absolutely do plan to do at least a webinar, and I do know the folks at the office would like me to do a seminar in the early summer. I listed an awful lot of topics there. Whether all of them can get covered, I don't know. But I would really like to encourage you, if you think, and I would like to help to make this workable, to pass my experience on and to organize things in a kind of way where you can find information you want. To set up means other than just putting together a wiki and documents that will inform and encourage and propagate this particular. I hope that I've covered this fairly well, and I hope that most of you have gotten something out of it, and I look forward to getting your feedback to figure out from your perspective where we ought to go from here. Thank you.
Okay, thank you, Barry. Thank you, everybody. What we'll do now is we are going to move to the final set of polling questions, and I will give these questions just a couple of minutes to give people an opportunity to answer. So please be sure to stay in the room and or stay on the line to participate in the questions and answer period, which follows directly after these polling questions, okay? And then one final reminder for everybody regarding questions. We will address all questions using the Q&A pod. So if you have a question, you should type those into the Q&A pod on the next screen when we're finished with the questions, okay? And then Barry will answer questions. All right, so I'll give it a minute, and then we'll move to the Q&A period. Okay, we're going to go ahead and move now to the question and answer period. I do notice that there are still participants typing in answers to the polling questions. Please feel free to email either Barry Weiss out at JPL, or you can email me and I can put you in contact with him directly for additional follow-up, okay? But in the spirit of time, we should go ahead and move to the Q&A period. And I do have a couple of questions already here, so hold on a minute. Okay. So first question, Barry, is any on orbit information as part of state vectors have position, velocity, and time. Those would benefit from grouping. Any thoughts of grouping of metadata in to give it more structure? All right, so I leave that to you, Barry.
I would agree with that. I mean, that's part I would like to do in terms of having some conversation about those on. What you should know about the LNR, those additional attributes that have state vector, is they actually came from the 5th ISO model, the 19130. However, it embedded in the 19130 model. Instead of trying to implement that and go down many, many different sets of classes to get to, we moved it up and made them additional attributes. However, classifying them or organizing them in some other way, making that part of an additional attribute scheme is something that would make good sense. I answered the question. And if not, the person should contact me and I'll further.
Okay, thank you, Barry. The question is, would dataset interoperability, WG, under ESDUG consider this with SCOPE?
It would. However, my concern about the ISO topic is it's so broad that if we just sort of picked it up like that, it would be very hard to come up with bite-sized or reasonable-sized goals. So if you wanted to do that, I think we should pick a particular set, one or two particular topics, and make them goals. Because as I think most of you see, this is quite broad if we do the whole list.
Thanks, Barry. The next question, can you talk about the relationship UUID and DOIs?
Okay, DOIs, I'm hoping that I have it right, and some of them may correct me. But it's a digital object identifier. By the way, one of the ESDSWG of the last 2 years has been working with this. So in this situation, and the DACs have done this with SMAP, they have generated these, basically they're URLs. And the URLs are defined to actually direct to a particular location or landing page. That landing page looks at the product and they see that I say this is why for this particular product. Or if on my documentation I say it's a DOI. If somebody then clicks on that, they will go to where the data are. But the advantage of the DOI is to say one DAC storage for this, and that DAC ceases to distribute those data, and the data are distributed somewhere else. At the appropriate moment, the data or else, the landing page immediately can be point to that other place, so that the landing page the person was using never changes on them. It will always point to where the products are. A UUID, on the other hand, is, by the way, UUIDs, you might be familiar with those if you're actually looking at all kinds of, particularly electronic information right now. But anything that is a new piece of electronic information can have a universally identifier associated with it. Every instance of a particular element can have a UUID, and then whoever want to reference that particular reference to where that is. Now, how that is used can vary tremendously. It doesn't necessarily mean that if you click on it, go find the product. However, if there isn't, to have that that used for people to find that particular element. So it basically enables the particular piece. But the UUID is specifically for individual. The DOI is for a whole set, a whole collection of granules.
Okay, great. Thank you, Barry. The next question is, do you have any example data files available with ISO standard metadata? If so, how can they be accessed? The question's really two.
Okay, well, the answer is yes, and the answer to that is what I think I could do right is probably provide some model. I'd have to double check. SMAP data is not going out to the general world yet. But I could certainly work with you where I probably could get some of this to people of this community. I don't think that would be an issue. You'll find some warts in it because we're still collecting it up and cleaning it up, but I would be more than happy to do that. One, because some of you might find some more issues, and two, you would probably learn from what we've done and be able to do more of your own work. Yes. So contact me. By the way, one thing I forgot to do, the very last slide of the slide present, and I know Jennifer will make that available to you, I do reference some other slide presentations that are on a wiki or on Ted Haberman's page, Ted Haberman, who is a true guru of ISO, where you might be able to get more information. I also have my email address, so please feel free to contact me. Go ahead, Jennifer.
Sure, and since you've mentioned that, just to note for everybody, in the lower right-hand corner here, the two files are available for download. You know, all you really need to do is highlight the file, and you should see and to download that file. So I've got the agenda, also the final presentation, which of course includes the last slides that Barry mentioned a moment ago. And getting back to the questions, and in fact back to the previous question, Rama had added that the digital object identifiers are used for citations, whereas, you know, in publications, whereas the universal unique identifiers are not. So
that makes sense. That absolutely.
Mm-hmm. And then, okay, so as a follow-up, and I should probably to everybody. So any of your questions that are captured here in this Q&A pod, there will be a log of these questions that will be sent to Barry Peters so that you know, he can easily work with any of the participants offline. So the follow-up is that the individual who asked whether or not there are example data files, yes, he would very much like to be sent an example. So you know, I'll be sending this file to Barry later on. Any further questions? See any at the moment? If you have a question, please go ahead and type the Q&A pod here. Okay, great. Okay, so where can we get a copy of the presentation? Okay, great. So the presentation, if you look below this Q&A pod, you should have in Adobe Connect, everything is called a pod, but you'll see a square where it says implementing ISO 19115 files. And there I have posted both the agenda, thank you, Barry, as well as the presentation. So if you simply highlight a file, right, I've done so, you'll see the option to download the file. I should also note that this feature within Adobe Connect is a persistent feature. So, you know, if you go to listen to the recording later on, and I'll send the direct URL out to participants and also those who registered but were unable to attend, you'll still be able to download the files at a later date. But I'll definitely follow up with information about where the file is been posted, etc. Then the next question is, did you encounter any major hurdles?
Of course. But boy, I mean, to think about what they are, I mean, what it really comes down to is because we were the first, among the NASA crew, we had to think very carefully about how we were using the metadata. And I found myself at times saying, and this is something, again, that I want to help others with, is okay, I see more than one field that by the loose definitions in these particular documents might be the right place to place particular elements. And it took time sometimes to get a better sense of which ones were appropriate and which ones were not, which again was part of what I was hoping to convey with some of the material I passed back to you folks today, where I do believe we have identified at least a reasonable number of them. And you also heard me mention some things that I'm really concerned about: configuration management of additional attributes. I'm very concerned about the fact that I want to work with the current model where missions are sort of separated from the data centers, but over the long haul, I see metadata changing and how metadata change happens and gets implemented. Also very concerned about, and this is something that I think is very important for those of you who do missions like I do. Missions are going to say, okay, we have a requirement to do this. Let's figure out how to get it in, get the minimal stuff in and get it done and clap our hands and say we're done with it. When the truth is there's a lot more here. And how do we balance what we can put in and still meet our budgets and schedules with what is required, which is generally the material that is needed for data discovery. So I see a lot of issues, and I think a lot of them are still there. I don't think they've gone away.
Okay, thank you, Barry. There is another question here, a question regarding citations. These are fields such as the abstract, where people might want to cite a document apart from the short description. How would you go about adding that?
Say that again. They're interested in an abstract.
It's a question about citations. There are fields such as the abstract, where people might want to cite a document apart from the short description. How would you go about adding that?
I guess it depends on the class, and this might be something that maybe I need to deal with the individual user on. Because in some situations, you can have multiple citations attached to a particular class. And if you can do that, maybe you can do that specifically without having to go about it. The abstract, as I see it in general, should be a descriptor. In other words, it should be text. That's the way it's defined in the ISO. So it would not contain a file name reference in general, and people would not expect to find one there. So I think this is more a question that I would like to deal with that individual, if that individual wants to identify themselves, and then talk about where we put it, and then figure out how we might go about it. Sorry that I'm not more specific.
So, Barry, I understand what you have just said, that you will address this offline.
Yes.
Okay, I've got the information, and I will email that to you.
Right, and by the way, anybody else who's interested in this topic, send me an email. I'll send it to a more general audience. It's not a problem.
Sure. Okay, well, thanks, Barry. Are there any further questions? Any further questions, anybody? So if there are not any further questions, I'll give it just another minute or so. What we'll do is in the next couple of minutes, we will log off from the telecon. However, I do plan to leave the, the meeting room, the online meeting room open, so that those of you who are interested in downloading Barry's presentation may do so. And certainly if you have additional questions, you may also feel free to type those into the Q&A pod, and I will email Barry the Q&A pod after we have finished. Okay, so he has all of your information. Any further questions? Doesn't look like it. Well, I'd like to thank all of you for joining us today, and thank you, Barry, for being the speaker on this topic. And I think we had discussed possibly a follow-up webinar, perhaps in April, following after the EOSDIS meeting. And so if you look to the thank you slide on the left-hand side, normally most data discovery or data access webinars would be announced at the URL that have noted there, tinyurl.com, Earthdata webinar. However, what I will likely do for the follow-up webinar is invite, the same group. It's more of an internal type webinar, so you will not find it listed on the public catalog. Although something to keep in mind, especially if you're teaching, we do hold monthly data discovery and data access webinars that generally each month will showcase or feature a different tool or data product from one of our 12 DACs. All right, so let me see if there are any further questions while I was speaking. I don't think so. I would like to thank all of you again, and we will now log off from the telecon. I'll leave the room open, okay, until 3:15 p.m. All right, thanks everybody. Thank you, Barry. Bye-bye now.